everyone, this is Global Education Zone and this is our crash mathematics course. And in this video I will be doing a continuation of the previous episode where I talked about laws of indices. So in this video I'll be doing some examples, and then we'll be finding the logarithm and the anti-logarithm of numbers. So let's delve into that. Now the first example we'll be doing today is 2a times 3 times open bracket 3a close bracket square. Now what that means is, my first example is I don't think that's visible. Okay, our first example is 2a times open bracket 3a square. So how do we approach this question? The first thing we are going to do is we are going to evaluate the bracket, because in our broad math rules the first rule is the bracket before the off, before the division, before the multiplication, before addition, before subtraction. So let's deal with the brackets first. That will be 2a. So, and in brackets, in default mode, you open brackets. That will be 3a raised to power 2. That's 3a in two places. That's 3a times 3a. That will be 2a. Now, one method of evaluating this is collecting the numbers by themselves, then collect the alphabet by themselves. So what we're going to do, we're going to collect 2, 3, and 3. That will be 2 times 3 times 3 times, then we'll now collect the alphabet. A times A times A times A times A times A. So it's just like collecting like terms too. So 2 times 3 is 6, 6 times 3, that's 18. 18 times A times A times A, that's A in 3 places, that's A raised to the power of 3. That's 18 times A raised to the power of 3, that will be 18 A raised to the power of 3. So that is an application of the laws of indices. Next, let's do a second example. This one is we are looking for the cube root of 8a raised to the power of minus 6. So number 2, cube root of 8a minus 6 raised to the power minus 6. Now anytime you see these questions, except the numbers are in brackets, the power is to the number that is closest to the power. So in this 8a raised to the power minus 6, it's only the a that has the power. But if they are in brackets, that means they both have the power. That's the difference. Now what we are going to do is the cube root. What does this mean? Let's first look for the root. We could do any one first. Let's see. What could we do first? Okay, this cube root, it also means 8a raised to the minus 6. Then you raise it to the power of 1 over 3. That's what it means. That's what cube root means. So it's just like raising 8a raised to the power minus 6 to the power of 1 over 3. So whenever you have two numbers in a bracket raised to a power, that means that power is multiplying. So that power is applying to both terms. So that will be 8 raised to the power of 1 over 3 times a raised to the power of minus 6, then raised to the power of 1 over 3. So that will be 8 raised to the power of 1 over 3. That's the cube root of 8 times a raised to the power of minus 6 times 1 over 3. That's a raised to the power of minus 6 over 3. Now this corresponding to one law of indices, that anytime you have a number in a bracket that has a power raised to another power, you multiply the powers. That's minus 6 times 1 over 3. That's minus 6 over 3. So the cube root of 8 is obviously 2 times a raised to the power minus 6 over 3. That's 3 in 3, 1. 3 in 6 is 2. That's a raised to the power minus 2. So what we have here is 2a raised to the power minus 2. That's the answer. We can also express it as 2 over a raised to the power 2. Because whenever you have a negative power, it is just like you are changing the numerator to the denominator. So a will go down and to change to positive. So these are examples on indices. And next, let's move on to logarithm. So how do we calculate the logarithm of a number? Now the logarithm of a number is the power to which we raise a base. So the logarithm of a number in a particular base is the power that we have to raise that base in order to get the number. For example, if we raise 10 to the power of 2 in order to get 100, the logarithm of 100 will be to the base of 10 will be 2. That would be represented as log 10 subscript, then 100 in a normal way. So let's just represent this as, for a number p will be equals to base b raised to power a. Let's call it like this. Good. So that means any number p can be expressed as the base raised to its logarithm. So now let me give an example. We are looking for the logarithm of 37.4. Now in this case p is what? 37.4. So in logarithms, except when you are told otherwise, you use 10 as your natural base. So what power would you raise 10 to get 37.4? So let's say 37.4, p is equals to b raised power a, but b is 10, right? That's p will be equals to 10, b is 10, 10 raised power a. Now that a is the logarithm of p, so we're looking for a here. So now the first thing you are supposed to do is to express your number in what? Standard form. So 37.4, when you want to express it in standard form, that will be 3.74 times 10 raised to power 1. That will be 10 raised to power a. Now, the next thing we are going to do is we are going to move on to a logarithm table. Now, this 3.74, we are going to look for the number in the logarithm table. Let's see. So we are going to look in the logarithm table from 37 difference 4. We'll look at 37 difference 4. Let's look at that. 37 in the logarithm table. That was 37. Under 37 we have 5, 6, 8, 2. So that's for when I'm looking for the logarithm from the logarithm table. That's under 37 we have 5, 6, 8, 2. Now our question is 37.4, right? So 37.4, 5, 6, 8, 2. Now you won't place your decimals yes until you get your final answer. So let's look for 4. Under 4 we have 37.4. That will be 5729. That becomes 5729. Now next, in logarithm, the logarithm of numbers between 1 and 10 lies between 0 and 1. So this 3 is between 1 and 10. So that means the logarithm of this 3 will be between 0 and 1. So that will be 0.5729. That would be the logarithm of these numbers. That's if we're looking for 3.57, if we're looking for 3.74. But if we're looking for 37.4, you move your decimal place to the right one value, because that's 10 raised to power 1. So you move to the right one. So the logarithm of 3.74 will be 0.5729. But the logarithm of 37.4 will be 5.729. So one trick is that whenever you have two numbers before your decimal point, you know that your logarithm will have one number before your decimal point. So that is one trick for calculating logarithm. So let's move on to anti-logarithm. Now, let's take this question. Use your anti-log tables to find 10 raised to power 2.7547. So we are looking for 10 raised to power 2.7547, and this will be equal to our number p. So we are looking for this. So that means we are looking for p. Now anytime you are doing the reverse of a logarithm, is known as the anti-log, and you make use of your anti-logarithm table. So you just go look at your table, and then you look at the fractional part of your number. For our number here, we have 2.574. Let me check that. 2.7547. So look at 7547, the fractional part. the decimal part. We look for that decimal part in the anti-log table. That's 7547. So when I'm looking at that in the anti-log table, that will be 754, that will be 4754 and 7. So after that, I've gotten 5684. So 5684. So when you have your number, your whole numbers, so that means you have 3 numbers before your decimal point. So we'll put the decimal point after the third number. So and this one, going back to this one, when you are looking for the logarithm of 37.4, that will be 1.5729. So I made a mistake there earlier on. So your whole number will be the power that 10 is raised to. So for 37.4, that would be 0.5729, but for 37.4, for 3.74 it is 0.5729, but for 37.4, that's also we express as standard form. Then we look for the logarithm of 3.74, then we'll now add 1 as the whole number. That will be 1.5729, and this is for the anti-logarithm. So thank you for watching.